So when we're talking about dilations, the one thing you always want to remember is that you always multiply. You always multiply. So I'm going to put that right here just as a good way to remember. It's always looking right at you. We're always going to multiply when it comes to dilations. Okay. So description and rules. The figure stretches or shrinks with respect to a fixed point. Okay. Now what that means is in algebraic representation, which is this right here, it means we always start, no matter what it is, we're always going to start at point x, y. Point x, y. It doesn't matter which quadrant this is in, if it's positive or negative. You always start, the preimage is always in x, y. What this means right here is that we're moving to a new location, or we're expanding this when it comes to dilations or shrinking it down. K, this is our constant of proportionality. This is our constant of proportionality. That means once you find it for one side, it is always true for the rest of the problem. And another thing we call this is K is what we call our scale factor. If you think about growing a business, people always want to scale their business. What that means is we're going to scale, or we're going to grow or shrink our business by a factor that is constant or doesn't change. Okay, let me show you an example of this. So, example 1, it says draw the image after a dilation having scale factor of 2. Well, a good thing to remember is this. This number, if this number is greater than 2, greater than 1. Sorry about that. If this is greater than 1, then it is growing, or it's going to stretch. If this is less than 1, then it shrinks. Okay? Now, so obviously, since it is greater than 2, it's greater than 1, we're obviously going to expand this. We're going to make it bigger. Now, the algebraic representation of this is going to be x, y. And what we're going to do is it's going to be 2x, comma, 2y. And the reason we do it on both is this. One thing about dilations is it always has the same shape, but it changes size. Well, if we were to expand this in different ways, or by a different amount in the x direction or the y direction, it would actually change shape. And then it would no longer be considered a dilation. So the way that you would write this is just like this. We're going to put our parentheses here. To find the answer here, we're going to multiply 2 times the x value. Well, that gives you 4. 2 times 2 is 4, so we're going to put that right there. Then we're going to do 2 times the y value, which is 3. This would give us 6. And we're just going to do the same thing on B and C. Now, what we call this here, this is going to be A prime. It's where we moved it after it was dilated. This is its new location of point A. Okay, this one right here, this is going to be B prime, and then we'll go ahead and put this down here for C prime. Now, point 3,1, we're going to multiply the x value times the scale factor. 3 times 2 is 6. 2 times 1, the y value, this is going to be 2. Okay, that is point B prime. And finally, C, we're going to go ahead and multiply that. 2 times 1 is 2. And then 2 times the y value is 4. Now what this does is because the value was greater than 1, again, it's going to expand. So as we draw this, you're actually going to see this shape. It will keep the same shape, but it will actually be a different size. So we're just going to go ahead and plot these points. So I'm going to go over 1, 2, 3, 4, and then up 6. 1, 2, 3, 4, 5, 6. This right here is going to be point A prime. This is going to be A prime. Now I'm going to do B prime. B prime, we're going to go to 6. So we're going to go 1, 2, 3, 4, 5, 6, and then up 2. 1, 2. This is B prime. Okay, and finally we're going to do C. So we're going to go over 2, 1, 2, and we're going to go up 4. 1, 2, 3, 4. And this will be C prime. I'm actually going to put it in a different color so it's easier to see as I draw this. Okay, so all we did was we expanded this shape. We expanded the same shape. Sorry, I'm not an artist. If you have a straight edge, it's always best practice to use some sort of straight edge to make sure that your lines are very straight. This will help from getting confused on any other by anything else. So all we did is we took this and we grew it by a scale factor of 2. So all we did was simply take the scale factor and multiply it times each x value and each y value to find our answer. Now let me show you another example. Example 2, draw an image after the dilation having a scale factor of 0.5. 0.5, well, we already know this is less than 1. This is less than 1, so it will shrink. It's actually going to get smaller. Now, we have this one. It spells out math. So what we're going to do is we're going to go ahead and set up our problem, m prime, a prime, t prime, and h prime. And go ahead and set it up, make it easy for you. I always like to try to do this ahead of time as far as setting up everything, because what tends to happen is if we have to keep going back and setting things up, a lot of times we'll forget a point or forget a step, or we'll get lost and maybe get distracted and forget our place, and it just leaves it open to more mistakes. So here's what we're doing here. We're going to write our algebraic representation. It's going to be x comma y. Again, we always start with x, y. And then it goes to, okay, and then we have a scale factor of 0.5. So we're going to put 0.5x comma 0.5y. 0.5x comma 0.5y. Now all we're going to do is just multiply 0.5 times each one of these. Now let's start with m. I have negative 6. Negative 6 times 0.5, that's going to leave me at a negative 3. 0.5 times a negative 4, that's going to be a negative 2. And at any time you're doing this, if you want to pause, that way you can test yourself and see if you can get the rest of these. Highly suggest that. Now let's go to a prime. I'm going to take negative 2 times 0.5. That's going to give me a negative 1. And do the same thing right here with a negative 4 times 0.5. That's going to give me a negative 2. Now this one right here, t to t prime is going to be negative 2 times 0.5. Again, that's negative 1. And negative 6 times 0.5, that will give me a negative 3. And finally, we're going to do 0.5 times negative 6, which is the same on both, so that makes it easy. It's going to be negative 3 and negative 3. Now, for most tests, especially most standardized tests, this is what you're going to have to do. You're going to have to be able to understand and either write or be able to pick the correct algebraic representation for this problem, and you will have to figure out points. A lot of times they're not going to give you a graph, but if you do have a graph, I highly suggest that you plot these points to make sure that it is the same shape and the same, but a different size. But I'll leave that up to you. I'll go ahead and do it for you just so you see how it works. So we said this was going to get smaller, okay, because the number 0.5 is less than 1. So here's what we're going to do. We're going to plot these points. So I'm going to go to negative 3, negative 1, 2, 3, and it says down 2, 1, 2. And put that point, and that is m prime. M prime. Now let's do let's do a prime. We're going to go to negative 1, and again, down 2. This is going to be a prime. The third one, we're going to go to t prime, which is down 1, minus 3. 1, 2, 3. I'm sorry, I did that backwards. It's going to be negative 1, down 1, 2, 3. So I'm going to put my dot here. This is going to be t prime. And finally, h, we're going to go to negative 3, negative 1, 2, 3, and down 3. 1, 2, 3. We're just going to draw our lines. And again, this is going to be h prime. Forgive me for that point right there. I wasn't paying attention. But right here, if you look at it, these are the same shape, but just different sizes. Now, we shrunk this down by half, which it's easy to see on this problem. We can just look at it like this. Another way you can check yourself is the distance from M to A, 1, 2, 3, 4 blocks. Well, if we cut it down by a half, it's only going to be 2 blocks. We're going to do the same thing here on the vertical. If we go A to T, that is 2, and we're multiplying that by half, so that's going to be our 1 right there. And that's how you figure out, or that's how you graph the dilations that are given to you. Okay. Now, the last little thing you want to know right here is we need to know the properties, and hopefully you've already kind of started figuring these things out just by watching the video. We need to know the properties of dilations, and these are very important because a lot of tests do ask you these kind of questions more than they ask you about the numbers. So the first one, pre-image and image. Pre-image and image they are similar, which means they are the same shape, but they are a different size. Similar, same shape, different size. The corresponding angles are congruent. Corresponding angles are congruent. This means, to simplify it for you, this means they are the same. Okay, and lastly, corresponding sides are parallel and proportional in length. Okay, so again, pre-image and image. And again, the pre-image, this would be, if we're looking at example 2, this would be math, points M-A-T-H, and the actual image afterwards, after the dilation, would be M prime, A prime, T prime, and H prime. So that's the image and the pre-image. So again, those are similar, which is the same shape, different size. The corresponding angles are congruent, which again means the same. That right there, that word right there, congruent, you need to know that. That's going to be everywhere you look as you get older and on these tests coming up. And then lastly, corresponding sides are parallel and they are proportional. They are parallel and they are proportional. Okay, so hopefully this helps you out. Dilations is a huge thing when it comes to bundle tests and standardized tests, so you want to make sure that you have this stuff down.